Okay, pause and copy, pause and copy. So we have a property here that may be familiar. Notice that we're talking about the length or the magnitude of u cross v. Not talking about u cross v itself. Okay, so this is a scalar quantity over here and over here. Now the proof of this thing, I've given a very brief outline here. Okay, the issue in Lagrange's identity is quite, it takes quite a bit of labor to work that out. Basically you have to, oh geez, what do? You go, what can you do? You go use the formula for u dot v here. Well, you gotta grind this out. Okay, you have to, no, I can't remember. Do you let u equal x, y, z, v equal, x2, y2, z2, and then work it out like that? Or, anyways, I forget which one it is, but you basically have to plug in a bunch of stuff here and then work out the left-hand side and work out the right-hand side, and oh, at the end you see everything cancels nicely and you get the same thing on both sides after half an hour. Okay, once you have that, part B is pretty straightforward. It's fairly straightforward to replace u dot v with the formula we have for that involving cosine theta. And then you can make your sine theta appear and prove that this is true. Anyways, just want to give you a quick outline of that. But let's see something geometric here. So we'll say geometry. Geometry. I want to look at this picture. Let's go like this. So let's say this is u, and we'll say this is v. In R3, of course, we got triangle theta here. And let us consider the parallelogram that these two vectors form. So you have a parallelogram like this, like that. And what is the area? What is the area of this parallelogram? Well, what can you do? You can do drop a perpendicular here, and let's call this length L. So the area is base times height. Base times height. The base is the length of u, and the height is the length L. Now, what is the length L? Well, you can go back to your trig and say sine of theta. SOHCAHTOA is opposite, so looking at this triangle, opposite over hypotenuse. So from that we get a formula for L. L is equal to, do I have space? AB. V sine theta. Sine. Barely. L is V sine theta. Plug that in there. And Bob's your uncle. So what was the point of that? Well, the area of this parallelogram is this quantity, which is this quantity. So it's u cross v. So it gives us another way of finding the area of this parallelogram. We can, rather than trying to, track down base and height in 3 dimensions, not easy for a parallelogram, we can just take the constituent vectors, cross them, do a length, and get our area.